I'm going to talk about incremental computation and databases. I'm going to talk about three things. A short story about the world today. Then we're going to take a quick trip to the past. And then we're going to go back to the future and see if there's anything we might want to do differently. First of all, quick poll of the audience. Who here loves Clojure? That's a little bit of a rhetorical one. Who here loves their database? Some, yes, but significantly less people love their database than their programming language. Ever wonder why that is? Let's start with a short story and see if we can get some insights why. The story is called The World Today. It's a fictional story, and any likeness with actual events is purely accidental. So it's a story about a company that is building their first product. So we're building a product, we're using a database and a web server. And the database in this case is Postgres. We've just gotten our first users, and we're really excited. The best part is that the users really love our product. They're using it all the time. They're calling our API hundreds of times a second, sometimes thousands of times a second. So they send a request, we take some data, we write it to the database, and we return a response. Pretty straightforward. Soon we get more users. We're processing more requests, we're making revenue, and we're officially in business. Postgres works great up to the point where it doesn't. So whether somebody issued a heavy analytics query at 5 p.m., querying the whole year worth of data, we actually don't know what the root cause is of the problem, but we do know that our database is down, our API is down, and things are clearly not working. We might try a number of reasonable options, but we finally decide to do the right thing, and we add a data warehouse. So, and of course, we do add a queue to copy the data over, and we hire some engineers to manage the system. And things are going well at this point, so we hire more engineers, and then we add another warehouse because Databricks, because our other engineers like that because it's good at AI. And then we add another queue, of course, to copy the data over there. At some point, somebody makes a critical decision to take some data, request data, user data, and write it directly to Databricks, to the warehouse. What the rationale for that is, we don't know, but it happened. The data is only there. Sometime later, we realize, actually, we really need to build a user feature out of that data. So how do we do it? Well, data warehouses are really great at responding to requests, but they might take 10, 20, 30, 60 seconds to respond. Our API needs to respond in 60 milliseconds, not in 60 seconds. So how do we solve that problem? Well, of course, we add another service called a reverse ETL service, and we copy the data back to Postgres so we can actually do some data transformation and finally answer the questions that our users actually have. So unfortunately, this is where most companies end up: high complexity and low momentum, and actually out of money. So it's game over. So can we do better? But before we jump to solutions, let's take a quick trip to the past and see how databases actually answer questions. How does a database answer a query? It starts with a declarative program in a language which might be SQL or Datalog. Database takes that declarative program and compiles it into a runnable code. And the result of that compilation is effectively a pure function. Then we take our database, we pass it to the query function, and we get a query result. Here's a question. How long does it take for that query to run and produce a result? 50 milliseconds, 50 seconds, 50 minutes, or more? Of course, it's a bit of a strange question because I haven't given you any information that's relevant to even begin to answer it, but let's assume it's 50 seconds. So let's do this again. Here's our database data, almost the same, but except for the new piece of data at the bottom. So how long does it take for the query to run now? This is a bit more straightforward. We kind of know from experience it should take 50 seconds again, right? So if you compare the two query runs, we have the same query, almost exactly the same database, and we have the same execution time. So is there any opportunity for improvement? Are we just going to redo the same computation over and over on the same databases and almost the same datasets every time? The truth is, most databases have not really changed since they were first invented. Yes, there's been some changes. perhaps columnar storage being a notable example, and yes, Datomic is absolutely great. But for the most part, only the packaging, at least for the popular databases, and the marketing is different. And crucially, and that's a very crucial point, in terms of query execution, they all start from scratch every time. So looking ahead to the future, can we do any better? I believe the answer is yes. Using incremental computation, we can actually stop recomputing query results from scratch. What incremental can enable us to do is get rid of extra services, data warehouses, random made-up acronyms, and we can actually get rid of those guys as well. So all we really need is our original database with an incremental query engine next to it, and possibly a queue. But in the future, we definitely don't need data warehouses. What we need is incremental computation. And the good news is that incremental computation is fully general. It can work with Datomic, Postgres and MySQL, even graph databases, and warehouses. It's really not coupled to a specific data system or paradigm. Pretty much, this is the only requirement. As long as a data system can provide a total order of diffs, transactions, or whatever the system calls it, it will most certainly work. However, Datomic, in my experience, is by far the best system I've seen that is the best fit for incremental computation. Immutability and the fact that it exposes a transaction log as a first-class feature really helps. So in conclusion, for incremental computation, with traditional query execution, there is no reuse, no efficiency between runs. With traditional query execution, time scales with the total data size, which is really not ideal. If you compare that to incremental computation, incremental computation enables efficient reuse between query runs, so we don't do the same work over and over again. And most importantly, the query execution time scales with the diff between updates. So as long as your data changes a little bit, and in the vast majority of use cases that I've seen, that is definitely the case, you can achieve single milliseconds response times reliably all the time. For the past year, I've been working on incremental query engine for Datomic. It's under active development, it's open source on GitHub, and we're pushing updates there every week. One last bit I want to leave you with, a data structure called Zets. They're an awesome fit with transducers. Transducers and Zets are the workhorses that make correct incremental query computation possible. Please come talk to me afterwards if you want to see how they work. But they're truly awesome, and since this is a Clojure conference, you know I can't say that lightly. Thank you so much.